Okay, so this is a video for our Unit 1, Topic 4 test review on rational expressions, solving rational equations, polynomial inequalities. There's some factoring in here. So for number 1, we have to factor this equation first to figure out what the zeros are going to be for our number line. So what multiplies to 15 that adds to 8 is 5 and 3. So setting each factor equal to 0, we get x equals -5 and x equals -3. So on my number line, I have to put those values in order from small to big, left to right. And then I'm going to pick some numbers to test in our factored equation, and I'm going to pick something less than -5, so I picked -10. Something in between, I'll pick -4. And then something more than -3, so I'll pick 0. So when we put -10 into the factors, we get a negative times the negative, which is positive. Then if I plug in -4, I get a positive times a negative, which is negative. And then if we plug in 0, it's going to be 5 times 3, so that's positive. Because the equation wants less than or equal to 0, I want the negative section. So that's when x is between -5 and -3. Because the problem starts with or equals, my answer has the or equals as well. Okay, for number 2, we need a common denominator. So between 3n, n, and 3, my least common denominator is 3n. So nothing has to change on the left term. This term needs a times 3, so I have to do the same to the numerator. And this term needs a times n. So we get n plus 5 over 3n equals 3 over 3n plus 2n over 3n. So since all the denominators are equal, I can set my numerators equal and solve it. So I'm going to move the n to the right, move the 3 to the left, and I get 2 as n. But I have to check for extraneous solutions, which means, does this answer make a denominator 0? Because we can't divide by 0. So no, 2 does not, so that is our answer. In 3, first we have to factor any denominator that can be factored. So this denominator shares a p. So my least common denominator is going to be p times p plus 2. So this term needs a times 2, and this term needs a p plus 2. So we get 4 equals p plus 2 over p minus, p minus 4 over p times p plus 2. Okay, so now all the denominators are equal. That's why I used a pencil this time and not a pen. I got my first term wrong. Let's fix that. It needs a p, not a 2. So that's 2p. If you caught my mistake, good job. Okay. Now all the denominators are the same, so I can set my numerators equal. And I put the parentheses here because this negative has to be distributed as I solve. P minus p goes away. This side becomes 6, so p is 3. Does that make the denominator 0? No and no. So 3 is our answer. All right, multiplying and dividing. And adding and subtracting. Okay, so number 4. I'm going to factor this numerator to x plus 5, x minus 5. It is the difference of 2 squares. So I can factor to the conjugates. This denominator has a common factor of x. So I factor out the greatest common factor. Okay, so now I look for any like terms. So x plus 2 divided by x2 is 1. X minus 5 divided by x minus 5 is 1. And our answer, we are left with x plus 5 over x. You may not simplify these x's. This is the final answer. For 5, dividing is the same as multiplying by the reciprocal. So I'm going to take the reciprocal of the fraction after the dividing sign. I'm going to factor this first fraction, so there's a 3x in the numerator that they share. And then the denominator, what multiplies to 4 that adds to negative 5 is going to be negative 4 and negative 1. X plus 2 divided by x2 is 1. X minus 4, x minus 4. So we are left with 3x over x minus 1. Subtraction, I need a common denominator, so I'm going to factor the left term. So my least common denominator is going to be x minus 4 times x minus 3, because both of those factors, this one already has one of the factors. So we have to multiply by 1, so anything divided by itself. So now this is I'm going to make this plus a negative, just so I don't forget that the negative is there. So my numerator, oh no, let's go back to subtraction. So then minus, so we have to simplify. I'm going to distribute the negative 3. And then combine like terms. So 4 and 9 adds to 13. And here's our simplified answer. And then lastly for 7, can factor this denominator. So my least common denominator is x times x plus 4. So this term needs an x plus 4. So the numerator is going to be x plus 2 times x plus 4. So we have to multiply these two binomials together. We get x plus x squared plus 4x plus 2x plus 8. Then any like terms we have to add, so that's 7x. And then we have to check to see if the numerator factors, because maybe it'll cancel with the denominator. So what multiplies to 8 that adds to 7? Ooh, nothing, because we could do 1 and 8, but one of them would have to be negative to get positive 7, so it doesn't factor. I can get rid of this. And this is our final answer. Okay, for number 8, oops, sorry, you can't see it. All right, for number 8, solving the inequality, I'm going to find, the numerator factors. No, it doesn't. 6 and 2. Oh, yes, it does. But nothing eliminates or cancels, so I don't need the factors. I can just set the numerator equal to 0 to find the zeros. And then the denominator of this 3, there's an asymptote here, if I think of the graph, so I'm going to exclude that when I test my number line to make sure that I'm going to include the right numbers. So I'm going to test something in each spot. So we have -10. I'm going to go back to the original. I'm going to use the factored form. So that's going to be negative, negative, and negative. So negative, negative, and negative is positive divided by negative is negative. You can use your calculator if you wanted to test the values. It's just a lot of typing, so I prefer to do it with my little signs. If I plug in 0, I get a positive times a negative over a negative, which is negative. 2.5 is going to be positive, positive, negative. So positive, positive, negative. That's negative. And then 10 is positive, positive, positive. Did I make a mistake? It's not usual that these are all the same. Did I make a mistake somewhere? Oh, yes. Did you catch my mistake here with the zeros? Positive times negative is negative divided by negative, which is positive. Okay, now we want less than or equal to 0. So here and here. So that's when x is less than or equal to -6, and when x is between 2 and 3. I'm glad I'm catching my mistakes as I go and not when I'm done the video. No way to go back and edit. All right, number 9, use long division. So we got x plus 2 divided by x to the third plus 3x squared plus x minus 1. All right, in the process, x to the third divided by x reduces to x squared, and I like to line up my terms. Then I'm going to multiply it back and subtract. So that's x squared, and then bring down everything else. Then we're going to divide again. We're going to do x squared divided by x. That's x. Multiply it back. X times 2. Subtract. So that's negative x minus 1. And then negative x divided by x is -1. Multiply it back. Subtract. We have a remainder of 1. So the remainder is 1. So our solution is x squared plus x minus 1 plus 1 over x plus 2. If you wanted to use box method, you could use it to check yourself. The only reason I'm saying you can't do it to solve the problem is because the directions specifically say long division. But I'll do box method just to show you. All right, so box method works. This goes back here. X to the third divided by x is x squared. Multiply, subtract, divide. Oh, that should be positive. 3 minus 2 is positive. Okay, so divide, multiply, subtract, divide, multiply, and the remainder is -1 minus -2, which is the same 1. So we get the same answer, x squared plus x minus 1, and the remainder of 1. Simplify and state the excluded values. Okay, we're going to factor the numerator. -6 to multiply to -6, but add to 5. We're going to do +6 and -1. So x cannot equal 1. It's going to be a whole since these factor. So let's give the coordinates of the whole. 1, when you plug it into the simplified version, gives you a y value of 7. All right. 2 more pages. Number 11. Oh, we got all these graphs with properties. Here we go. The roots are your x-intercepts. That is when 2x plus 1 equals 0, and that's at -1/2. Vertical asymptotes is what makes the denominator 0. Horizontal asymptote, I compare my degrees. Since they're the same, I divide my leading coefficients. End behavior is as x goes to infinity, we will always approach our horizontal asymptote. And symmetry, prove algebraically, means I can plug in the same value for x, positive and negative, and see what we get. So let's plug in, I don't know, 5 and negative 5. So that's going to be 11 over 2. So negative 5, that's going to be negative 10 plus 1 over negative 8. That's negative 9 over... These are not the same, they're not opposite, so this is no symmetry. Okay, the roots of g of x is when the numerator equals 0, so that is at 4. Notice I'm not writing x equals or x equals. That's a vertical line, and since these are just roots, which are x-intercepts, we just want the number. You could give a coordinate like 4, 0, but that's more writing. You can just give the number. Vertical asymptotes is what makes the denominator 0. Oh, Miss Weiss. Wait, we didn't simplify our equation. Uh-oh. Back up. Got my good eraser. Okay. I should have simplified the equation to start, because there's a hole, which is not asked for, but I'm going to give it, because why not? We have a progress check / quarter exam coming up. So there's a hole. So using the simplified equation, the numerator never equals 0. So there are no x-intercepts. The vertical asymptotes is what makes the denominator 0. And let's talk about the hole while we're here. The factor that canceled has x value of 4 to make it 0. So to find the y-coordinate, I plug the 4 into my simplified equation, and I get 1 over 8. Aha, okay. Horizontal asymptotes, the numerator degree is smaller than the denominator degree. That's why there's no x-intercepts, because that's an asymptote on the x-axis. End behavior approaches your horizontal asymptote. And for symmetry, I'm going to plug into my simplified version. So let's use 5 again. Oops, it's G. Okay, so 5 is 1/9. Negative 5 is negative 1. That's neither. This time I'm going to be smart. I'm going to factor first. Nothing simplifies, no holes. So we have some x-intercepts. That is when the numerator equals 0. So that happens at negative 2 and positive 2. Vertical asymptotes, what makes the denominator 0. Horizontal asymptotes, numerator degree is bigger than the denominator degree. So there is no horizontal asymptote, it's a slant asymptote instead. And it doesn't ask me for that, and my video is already almost 20 minutes, so I'm not going to find it. But for the progress check, you'll have to know how to divide like we did here. We divide to find a slant asymptote. For end behavior, I'm going to look at my graph, because with a slant asymptote, these are either going to be positive or negative infinity. Got my calculator. Now, when you put the numerator into y equals, you must put parentheses around it. Same thing with the denominator. Oop, my window. Zoom 6 for a good window. All right, so as x goes to infinity, my graph is going up to infinity. As x goes to negative infinity, the graph is going down to negative infinity. And here's that slant asymptote going across the screen. Symmetry. I'm gonna look at it. It has none. Not y-axis, not origin. None. Factoring. Factoring is forever in math. You are never done with factoring. What multiplies to negative 32 that adds to negative 4? We're going to do negative 8 and positive 4. What multiplies to 2 that adds to 3? Is 1 and 2. What multiplies to negative 5 that adds to 4? We're going to do 5 and negative 1. Multiplies to 14 that adds to 9. We're going to do positive 7, positive 2. Multiplies to 4 that adds to 4 is 2 and 2. Multiplies to 18 that adds to negative 9. 1 and 18, 2 and 9, 3 and, oh, it's going to be 3 and 6. X minus 6, x minus 3. 9 to get 6 is going to be 3 and 3. Multiplies to negative 8 that adds to 2. Positive 4 and negative 2. And multiplies to 8 that adds to negative 6. It's going to be negative 4 and negative 2. Oh, more factoring. Difference of two squares, oops, sorry, is conjugate, so x plus 4, x minus 4. 64 is the perfect square for 8. No, it's not. Yes, it is. And then 4 squared, excuse me, what squared equals 4 is 2. So we have 2 and negative 2. In this one, we have a greatest common factor of x divided out. Oh, this one also has a greatest common factor of x. Again, a greatest common factor of x. 4x and 12 share a 4. And 4x and 8 also share a 4. All right, complex fractions. Since we have fraction over fraction, we can multiply by the reciprocal of the denominator. The x squared minus 36 can factor. Ooh, and these simplify. 2 goes into negative 6 3 times. So we are left with negative 3 over x plus 6. No, you may not cancel those. And last but not least for 14, the x squared minus 1 comes to the numerator, and I'm going to factor that difference of squares as I write it. The x squared minus 6x plus 5 becomes the denominator when I take the reciprocal. So we're going to do negative 5 and negative 1. Those are 1. These are 1. The whole thing is 1. When everything divides away, it's 1, because this over this is 1, 1, 1, 1, 1 times 1 times 1, 1 times 1 times 1, all 1. I hope you enjoyed the test review.